Okay, so we're going to do 2.3, 21 through 25. I'm probably going to do a couple of these and have you practice on your own. For each of the geometric sequences below, find the missing terms in the sequence, then write an explicit rule for the sentence. So the very first thing that I want you to do is I want you to remember what we are actually doing. So we have to do this division statement. So we go 162 divided by 2. So 162 divided by 2, that's 81, right? And so from here to here, we have 4 jumps. So 1, 2, 3, 4. So basically, I'm looking, so what to the 4th equals to 81. And then you could try different numbers like 1 to the 4th is just 1, so that's not helpful. 2 to the 4th actually turns out to be 16. So that's not helpful. And in case you're wondering how am I calculating this, it's 2 times 2 times 2 times 2, which is 16. I'm going to try 3. 3 times 3 is 9. Times 3 is 27. And then that times 3 was 81. So that's actually my multiplier. So I'm going to multiply by 3 here, by 3 here, by 3 here, hopefully ending me with 3 here. 162. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And I'm hoping that 54 times 3 is 162, which it is. Okay. So then I want to write an explicit equation for this. And there's not only one answer for this. So I'm writing an explicit equation, not necessarily the explicit equation. And I'm just going to show the more popular one, if that makes sense. I'll explain the other one just so that you have an understanding like, oh, I see where that comes from. So the explicit equation for this one is going to be y equals to 2 times 3 to the n minus 1. Now, the 2 comes from this 2, right? The first term. The 3 comes from my multiplier or my common ratio. The n minus 1 has to do with me playing with what number needs to be there, either n or n minus 1. So because I know that we're using 1, I use n minus 1. And then I'd plug them in my numbers just to make sure that they'd work. So I'm going to plug in, let's see, 4. So 4 minus 1 is 3. 3 cubed is 27. 27 times 2, yeah, it's 54. So I'm good. So the other answer for this is very interesting because it's 2 times negative 3 to the n minus 1. And the reason why both of these answers could work given the table that they gave you is because negative 3s to the even powers are just, to the even powers would just give you positives. So some of the numbers in here would have to change to negative, but my point is there's more than one answer here. Ms. Johnson, how do you know which answer to put? So they just said to write an explicit rule as if there could be more than one. And one of them could be represented by the same one, just, kind of like an equivalent version of that, right? Okay, so let's do the next one, number 22. It says this, and I'm going to do it the same exact way. I'm going to go negative 3 divided by 1/9. And if you remember, if you divide by a fraction, you're really multiplying by the reciprocal. So that's 9/1. So that's just negative 27. So I'm looking for what to the something equals to negative 27. So this is 1, 2, 3 jumps. Let me let my computer catch up to me. So this is 1, 2, 3 jumps. So I'm looking for what to the 3rd gives me negative 27. Hold on a second. Let me get this to catch up. Okay. So you're looking for what to the 3rd equals to negative 27. And if you paid attention over here, that's just going to be negative 3. And the reason why it's going to be negative 3, not 3, is because I have this negative 27. And so negative 3 times negative 3 is 9 times negative 3 would give me negative 27. So my multiplier here is negative 3. Okay, so I'm going to be multiplying by negative 3. So this would be negative 1/3. This would be negative 1. Oh no, positive 1, sorry. That would be -3, and then this would be 9. Okay. So that's me filling it in. And then I'm going to use my equation. So y equals ab to the x. So a in this case is 1/9. Your base is -3 to the x minus 1. Because they gave me the first term, then I'm going to move it over by moving it left 1. So that's -1. Okay. So same thing goes here. You're still doing the same exact thing. Some of the numbers get a little bit intimidating, but the method is exactly the same. So 0.625 divided by 10 is 0.0625. Right? And I have 1, 2, 3, 4 jumps. So I'm thinking of what to the 4th gives me 0.0625. Now here, because this number is a little bit tricky, I'm going to go to my calculator and I'm going to use the fact that I know how to find the root of this. So I'm going to find the 4th root of 0.0625 by going like this. And if you remember, your fractional exponents are really just roots. So it's 0.5. So what I basically just found is 0.5 to the 4th is 0.0625. Okay, so there's my answer. My answer is 0.5. That's my multiplier. So it's basically half times by 0.5 times by 0.5 times by 0.5, right? So I'm going to fill these in. I got 5, and then I got 2.5, and then I got 1.25, and then I got 0.0625. So then my multiplier, my equation is going to look like the same. Y equals ab to the x minus 1. A in this case is 10. B in this case is 0.5 to the x minus 1. Now, if you notice, sometimes I use x minus 1 and x, but because, again, they gave me my first term, I'm going to use x minus 1 here. Okay. So this one looks weird because it's letters, but it's still the same. So I'm going to find this, and so I'm going to do the same exact, protocol. So I'm going to go gz to the 4th divided by g. Well, if you see, the g divided by g is just 1. So it's z to the 4th. And if you notice, I got 1, 2, 3, 4 jumps. So I'm thinking, what to the 4th gives me z to the 4th? Let me let that catch up real quick. Yeah, and then you're like, wait, doesn't a z just go there? And you're like, really, is it that simple? And the answer is yeah. So the z just goes in there. So we're going to multiply by z because that's our multiplier, right? And so that's gz squared, gz cubed, gz to the 4th. So it works. So as weird as it sounds, we're going to write our equation as our first term, which is g, times our multiplier, which is z to the x minus 1. And you're like, Ms. Johnson, that looks so weird. And I agree with you. That looks really weird, but nonetheless, it's still the answer. All right. Last one, number 25. They still want you to do the same thing, except for here, they just want you to find the slope in each case. So again, slope for me is the change in y. So this is -7 divided by the change in x, which is +2. So here our slope is -7 over 2. Okay. Our slope is always going to be the change in y divided by the change in x. Have a great day.